Hello, 87. Thanks, as always, to those of you that are submitting your work. I'm recording this at about 1 o'clock on Thursday, and I don't see a ton of stuff added yet in the Earthship slideshows. So please get to that. That should be a priority. I noticed that there are about 5 conflict minerals submitted. Great. I'm going to take a look at those and mark them tomorrow. And the geography stuff, I'll give a big, broader feedback video later, but there's been a bunch come in and come back. So those of you that have submitted already, thank you. The maps are really cool. There's a couple of them that really stand out. Maybe we can find a way to share those. So if you're kind of a little behind on that, it's okay, but try to get to it. If there's something that's standing in the way, if the Nelson textbook won't open, or if it feels like too much work, or if you've got specific questions, many of you have emailed me specific questions. I love reading them because it's some interaction for me, which is important. But yeah, get that work in. Today's video is a little different. It's an interview with a man named Gary Mottershead. Gary, as you'll see in the interview, he started and runs a rubber importing company, but got to start recycling tires and talking about what tires are made of and why they're so hard to break down and why they are such a good material for earthships. So it's a little longer. I think the interview itself is 10 minutes. I think it's worth watching. And keep emailing me your questions. Enjoy the interview and have a great weekend, 87. Okay, so good morning, 87. With me here is Gary Mottershead, and Gary's the founder and the president of a company called GCP in Kitchener. And my connection to him is that one of Mr. McDonald's longest friends has worked at GCP for, I don't know, how long has Nate worked at GCP, Gary?
15 years now.
15 years now. And so when I started developing this Earthships assignment, I thought maybe Gary could speak to this because he's got a lot of experience in rubber, which they do now, and then before that with tires and tire recycling. So I'll let Gary go. Gary, can you tell us a little bit about tires, why they're so hard to break down, and kind of your innovations in trying to recycle them or divert them from landfills?
Yeah, good. Thank you very much, and good morning to everybody. Delighted to be able to speak with you to the class. The key thing about tires is that tires make up about 75% of the rubber that's used in the world, a tire is one of the most engineered products there is. If you can imagine the stresses on a tire as it's taking a car hurtling down the highway at 100 kilometers an hour or more, or whatever. So it's really structured very, very strongly. Again, and a great idea to use it is in the structure in a house, the Earthship that you're building, because it's got steel on the inside, it's got rubber, it's fabric, it's all reinforced. So that structure that makes it safe for all of us to use on our vehicles, whether cars, trucks, or even earth-moving vehicles, also is what makes it very difficult to recycle. When the structure of it is difficult. And the other part about recycling a tire that's quite a bit different, and I only have to use one technical term in the sense that rubber is what we call thermal set, so that when it's cured up, it actually has bonds that tie up like knots, and they don't come apart easily. Plastic melting come apart easily. Glass breaks down and can be melted back again. Cardboard can be repulsed again. Rubber cannot. Rubber is already made and doesn't like to come apart. So you have to use an awful lot of energy to take it apart. So,
Gary, sorry, it sounds almost like if you melt wax together. Would that be an appropriate analogy?
Except as wax, you can melt it down and then reform it into a candle, right? If you melt rubber, it goes into a puddle and doesn't want to come back to shape again. And therefore what happens to it loses all of its properties. Thank you for breaking that. It's if you rip it all up and then expect to just put it back up, why doesn't it work again? Because you've ripped all you really cut everything that makes it work. And so inside what they call the bonds that are there. So I know it's a bit technical, but the reality is you'd actually destroy the material when you melt it. You can't reform it back together again as you can with a plastic or a wax in this case. Even glass can be melted and then reblown back into glass again. So when you do melt it down or break it up and form it back in again, you don't end up with all the properties. You lose some of its value, and therefore, because tires use up most of the rubber, they don't, I would say it's hard to put that rubber back in because you need to be very high quality, and you need it to bond to steel. You need to bond to nylon and fabrics that are in there that reinforce the tire. So that's the challenge. So you've got all these tires. We actually, it's about 1 tire per person, adult person that is disposed of each year in North America. So it's how many million tires. But if 75% of the rubber is used to make a tire, and now you got all these tires that are going out, you've only got 25% of the rest of the rubber world, of which is not enough space for it to go. There's not enough places for it to go. So that's why other uses for rubber have been found. Rubber is a fabulous product, but it's very specific, and all rubber is not the same. You have different types of compounds, and won't get into that are used to be able for sunlight or for oil or other resistances. So rubber is a very complex product that is derived from oil. So that's what makes it's a good product, but what also makes it challenging for the same reason that it's good.
And when you developed your I don't know what to call it, tool, process, machine for breaking down tires, can you tell us a little bit about all that goes into? So we've got this incredible product that's bonded together. It is possible to break it down, but it's a lot of work. Can you tell us a little bit about that?
Yeah, and this goes back a long time. I started this back in 1989. My daughter was just born. She's now 30 years old, so it's gone a long time ago. And literally, what you have to do is now you have to break it from this large piece in something smaller. And so the first thing you do is what they call shred it through a machine like a paper shredder. You've got paper shredders at school. They take it into long strips or little squares. You shred the tire. Then in our case, we used something that was very unique, is we use liquid nitrogen. Liquid nitrogen has a temperature of about minus 180 degrees Celsius, and rubber has to get down to 120 degrees Celsius to be able to be brittle. Once it's brittle, like glass, it can be smashed and it can be broken. So we put liquid nitrogen in one end, and we put tires in the other end of a tumbling chamber, froze it down, these chunks about that big, and then we dropped it into basically a continuous hammer, what they call a hammer mill. And from there, we smashed it up. And just as you would glass as it shatters when it hits the ground, or you put a hammer to it, it breaks into different sizes. But the nice part about when it's frozen, the steel and the fabric would break away from the rubber. So that's what made freezing so nice.
And these are products that are woven into a tire to give it some strength.
Yeah, all woven in there. So that's what for the sidewalls and for around where the treads are, so that they don't puncture easily, and they have all the strength to be able to stand up to the conditions the really very strenuous conditions we put the tires on a road. So then from there, what happens is now we have all this rubber, and then we would convey it into a place where we'd separate it. We'd use magnets to get rid of the metal. We'd use a screen to get rid of the fabric, and then we'd separate the rubber into various sizes. So some of the ones you can use it for ground cover, so people can put it on their lawn, in their gardens, for example. It was used in sports fields, as we've discussed just in getting ready for this call, and they're used in soccer fields and football fields primarily.
So I just interrupt everybody. What Gary's saying, if you've ever been on a turf field, there's little bits of rubber. What Gary's saying is that's broken down tire.
Yeah, that's broken down tire, and the reason is it lasts a long. That's the other thing about a tire; it lasts a really long time. It's designed to last a very long time, and that also brings a challenge to it. A lot of other products break down in sunlight. Tires go on 20, 30 more years than that. So it was great for your homes that you're building, but not so great for other things. Anyway, so once you've got it, you have to get it in different sizes, and then those sizes become useful for different applications. They can be combined with plastics again, to be put back into rubber, maybe used in sports fields. One thing that everybody would notice when they're driving around, if you ever see the traffic cones that are at the side of the road, orange ones, whatever, there are two types of bases that hold them down. One is they cut out what's called the center part of it, which is heavy, or the heavy part of tire cord, and they'll use that for weights because there's a lot of metal in it. Or they'll take all those small little bits and press them together with glue and make a compressed base. And you'll see those around on the side of the highways or in parking lots. And so the rubber's getting used in those type of applications.
Okay, Gary, thank you. So what I'm hearing is that what makes one of the great things about tires is that they're strong. They can last on the
Sure.
road and under all the stresses that cars and driving put on them. Problem is, once they've finished with that part of their life, we don't know what to do with them, and they don't break down. And so in adding liquid nitrogen, all the pliability that comes with rubber, you need to fight against that.
Right.
Adding liquid nitrogen makes them brittle, smash them up, can use them for other stuff. Or in this case, save yourself all that time, fill them with dirt, build a wall.
Now, I will say one thing, that I did that for about 10 years of my life. And then the business of GCP is we found companies in China, actually, that use tire rubber, and they do what we call devulcanize it or melt it again, combine it with new rubber, and we make new rubber sheet with it. So GCP is the largest importer of industrial sheet rubber into the United States and Canada, and we use that tire rubber up again back into rubber applications. Not the same high quality as a tire, but in conveyor belting and in all of our sheet rubber products. So I've been involved in recycling tires since 1989, and the last 20 years is really bringing in products that people use. You wouldn't necessarily see it if you go to our local Princess Auto. We can't go in right now, but when we can go in and you go and look at the matting that they take, you can take it off a roll and cut it. That's all our product, and that's all made from recycled tire material.
So the tire is the tire kind of the top of the food chain in terms of rubber quality, and as you recycle and repurpose, it degrades a little bit each time.
Correct.
Okay.
But you can keep adding more things in to bring it back up a little bit.
Okay.
But the two things, you never take it back to those very high pressure, whether it might be hoses or tires, but the rest of it all gets reused. So I made this my life's purpose in a lot of way, and my something that I wanted to do back 30 years ago, and have found a way to continue to quietly be involved in recycling tires all that time.
Okay. Thank you, Gary.
You're welcome.
Don't hang up yet. I'm just going to end the recording here.